Hello, and welcome to the Verification Academy. My name is Dave Rich, and I'm a verification architect with the Design, Verification, and Technology Division of Mentor Graphics. This is the SystemVerilog OOP for UVM Verification course. I'm going to introduce you to a small part of the SystemVerilog language called the class. Let's begin with a brief introduction to OOP. The class data type in SystemVerilog is the construct enabling object-oriented programming found in many other languages. From an academic standpoint, OOP encompasses a few key concepts which I'll briefly mention here. Encapsulation, creating containers of data along with their associated behaviors, basically the code that operates on that data. Inheritance, the ability to extend or override those containers with additional data and new behaviors. Data hiding, more specifically, hiding the implementation details, reducing complexity, while at the same time raising the level of abstraction. Generic programming, the ability to write code that can be reused for a wide range of applications. For those of you already familiar with Verilog, this is like overriding parameters on a module instance. And finally, polymorphism, a big word but a key simple concept. This is the reuse of the same code to take on many different behaviors based on the type of object at hand. This ties a lot of the concepts above together. We'll be going into more of this in later sessions. So what's the purpose of all this? Well, it's writing reusable code, especially for verification environments. And if you didn't realize it already, writing a test for hardware is a software problem. And OOP is a proven methodology for writing abstract, highly reusable, and highly maintainable software code. So where did object-oriented programming come from? Well, it came from an early hardware description language called Simula. HDLs are very conducive to objects because you can think of hardware as a collection of connected components, with a component forming the basics of an object. Verilog is in many ways an early OOP language, with a module being the basic object that gets instantiated to make up a design. C++ was created by merging the concepts from both Simula and C. But one of the big problems with C and C++ is its poor memory management. It's too easy to reference invalid memory or corrupt someone else's memory. You wind up spending a lot of time debugging someone else's code instead of your own. Sun Microsystems developed Java as a highly reliable alternative to C++. It takes care of all the memory management for you and makes it very difficult to write corruptible code. It was originally called C++, meaning it was C++ subtracting the bad parts of C++. Around the same time, Sun's hardware teams began to realize that even though Verilog was designed as both a design and test bench language, it was running out of steam as a test bench language. So Sun merged a lot of the concepts from both Java and Verilog and created the Vera language. However, Vera was a separate proprietary language that bolted onto a separate Verilog simulator. Eventually, Vera merged into Verilog and became what is now known as the IEEE SystemVerilog standard.